Episode 65, titled Manage Cloud Data Protections, SLAs, and Provider Risk, we link cloud data safety to 3 levers you can actually steer: encryption choices that fit each dataset, resilience promises that hold under stress, and vendor reliability that does not waver when headlines arrive. Cloud speed only helps when your protections are explicit, measured, and testable, so we will speak in plain terms about who holds keys, how restores are proven, which thresholds trigger escalation, and where provider health signals land. The end state is not a pile of options. It is a short, coherent story for each workload that says what protects it, how fast it recovers, who calls whom when things wobble, and what evidence proves the claims. That story travels with the system, so decisions in a sprint review match behavior on a Saturday night. Backups and replication patterns must be more than checkboxes. For each workload you set recovery time objective, RTO, and recovery point objective, RPO, in minutes or hours that a business owner accepts, then you choose patterns, multi-availability zone snapshots, cross-region replication, streaming logs that actually meet them. Immutable backups with versioning and legal hold options cover ransomware and accidental deletions. Point-in-time recovery for databases covers operator error and schema missteps. Object lock type controls keep adversaries from racing you to erase history. Verification is a rehearsal, not a spreadsheet. You run restores on a schedule, measure the time, compare data freshness to the promised RPO, and record the artifacts, job identifiers, checksums, and sign-offs. Where restores are slow, you fix before the next quarter, not after the next incident. Service Level Agreements, spelled SLAs, align provider guarantees to business impact rather than marketing tiers. Availability targets tie to allowed downtime per month and the systems that absorb it: active-active for customer-facing services, warm standby for internal tools, and cold restore for bulk archives. Performance targets map to tail latency and throughput thresholds that matter to end users, not lab conditions, and they cite the meters you will check when a dispute arises. Support SLAs describe first response and escalation windows by severity, plus who participates in joint calls and how evidence is shared. Each SLA includes a remedy, service credits, contractual penalties, or step-down clauses, and a trigger for business continuity actions when credits are not enough. You keep a one-page translation from SLA terms to operational playbook so responders know exactly what 4 nines means to today's release. Providers are systems too. You monitor them as you do your own. Health checks track status pages, component-level incidents, maintenance advisories, and regional impairments with normalization so signals feed alerting rather than social media. You subscribe to change calendars, record relevant incident histories, and maintain a short mapping from provider components to your workloads so a degraded queue or identity plane turns into named owners and clear actions. Alerts that cross thresholds pull a pre-written contingency shift, traffic, slow batch jobs, pause migrations, and a communications plan to customers and partners. Each event leaves a short file, timestamps, affected services, decisions made, and recovery confirmation. Over time, this dossier makes risk visible to leadership beyond anecdotes, and it calibrates which providers match your appetite. Preventing unintended exposure in cloud services requires controls on both destinations and contents. Egress policies convert any to internet into curated allow lists for resolvers, update services, partner endpoints, and sanctioned APIs, while service-to-service communication prefers private links or endpoints to avoid needless public paths. Data Loss Prevention, or DLP, watches for sensitive classes crossing boundaries through mail, storage, and web gateways, tuned with fingerprints and exact data matching to cut false positives. Tokenization replaces selected fields with reversible tokens, so logs, analytics, and lower trust services never see raw secrets. And detokenization is limited to high trust zones with audit-ready receipts. When combined, these controls turn "we rely on good behavior" into only named paths with clear evidence move critical data. Cloud services throttle and limit by design. Ignoring those ceilings creates self-inflicted outages. You track quotas, burst allowances, concurrency caps, and per API rate limits as first-class configuration alongside scaling rules. Load testing validates not just application code, but also provider envelopes, recording where requests are throttled and how back-off policies behave under pressure. Where limits are too tight, you file increases well before launch. Where limits cannot rise, you shard workloads or add buffers to ride peaks. Dashboards show service credits consumed, throttling errors by call site, and the top talkers that should move to batched patterns. This preemptive stance makes peak seasons uneventful and keeps postmortems focused on improvements rather than apologies. Third-party risk is a discipline, not a form. Critical providers undergo formal reviews that cover financial stability, security controls, development practices, supply chain exposure, and data handling specifics aligned to your classifications. Independent penetration tests or red team results are requested and reviewed, with remediation evidence tracked to closure. Where tests are unavailable, you scope your own with contract language that respects boundaries. Exceptions become risk register entries with compensating controls, stricter logging exports, tighter egress, or reduced data classes, and owners sign off on the residual risk. Renewal cycles require fresh attestations and a quick variance report against last year's posture. The result is a living picture of vendor reliability that informs both procurement and architecture. Exit and portability are planned before contracts are inked so that leaving never becomes a crisis. You specify export formats for each dataset, document schemas, and transformations, and confirm that re-imports into a fallback platform succeed with reasonable effort. You maintain decommission runbooks that list owners, steps to drain traffic, sequences to revoke credentials and keys, and the proof you will retain of data deletion on the provider side. Pilot exports run at least annually for crown jewel datasets, with measured transfer times and integrity checks that match production scale. When an acquisition, price shock, or service regression arrives, you already know the cost and the calendar to move safely. Several predictable pitfalls deserve explicit safeguards rather than hope. Unbounded costs are capped with budgets, alerts, and automated pausing of non-essential jobs when spend curves exceed plan. And cost tags are enforced in pipelines, so unknown never becomes a budget line. Noisy neighbor effects are mitigated with instance and storage choices that provide isolation guarantees, plus SLA language that addresses contention, not just uptime. Weak backups disappear when restores are measured and reported like uptime, and when immutable copies live in a separate trust zone with distinct credentials and keys. Each safeguard is paired with a small metric that shows drift % untagged resources, throttle errors per million requests, restores that exceeded RTO, so fixes start early. A practical scenario shows resilience in motion during a regional impairment. A customer-facing service runs active-active across multiple availability zones in one region with asynchronous replica in a second region. When the primary region's control plane degrades, health checks failover read and write traffic to the secondary region via pre-approved routing changes. Stateful data follows through log shipping with known lag, and the application advertises a temporary read-only mode for a narrow slice of features that cannot tolerate delayed writes. Background jobs slow to conserve quotas and cost, while status communications post on a predictable cadence. After recovery, traffic shifts back under supervision. Replicas reconcile, and a report pairs SLA targets to observed metrics with the exact timestamps of crossings. Customers see degraded but coherent service. Auditors see receipts. Teams see where to shave minutes next time. To keep leaders, engineers, and auditors aligned, you provide a review queue that links data class, SLA, and chosen protections to a single dashboard. Each workload tile states its classification, the at-rest and in-transit encryption modes, the key custody model, the current RTO and RPO targets with last restore time, and the SLA health against availability and performance SLOs. It also shows provider status overlays, top throttling sources, open risk items, and upcoming contract or limit renewals. Clicking through reveals artifacts, key logs, restore transcripts, incident tickets, and penetration test remediations, so the path from red to green is never a mystery. This queue makes conversations concrete. When a product expands to new regions or data classes change, everyone sees what must change with them. We close by directing maintenance that keeps posture current. Update the provider risk register for your top services, verifying that SLA terms match today's business impact and that the latest incident histories and financial signals are captured. Run targeted backup tests for the two most critical workloads and record RTO and RPO results with checksums and approvals, adjusting patterns where reality missed the mark. Review exit options by confirming export formats, testing one sample transfer, and validating decommission steps for a low-risk tenant. When these actions are recorded with owners and dates, cloud data protections stop being abstract comfort and become a predictable set of choices, rehearsals, and receipts that you can defend in the room that matters. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.